So, hi to everyone. My name is Daniel Ramirez, and well, my colleague Alexander Antukh is on the first line. So, this presentation will be split in two parts. The first part will be about Android reverse engineering, and the second one about some samples about Android malware that it was on the Google Play, but now they are removed from them. So, more or less, the agenda for this presentation is explain a little bit about what is an APK and the different way that we can get this APK to start to work to do the reverse engineering process. Then explain difference between the compile, the Android application, and disassembly the application. Then introduce a little bit about what is the SMALI files, and then some techniques about how we can mitigate the lack of binary protection in our application. And then on the last part of the presentation, some malware analysis. So an APK is like the previous talk. We say it's similar to it's like a zip. So inside the APK, we can find the following files. So one of the most important files is the Android manifest.xml. That during the developing of the application in the Android Studio, for example, is just like a XML file where you will define there all the permission that the application need to that the application need to use it. And then after it will be like a binary file. Then the class.x that there is where all the Java source code are compiled in the Dalvik virtual machine. Then we have the meta.in folder that is where are stored the certificate of the application. Then the rest folder where you can find all the resources that the application might need for work, like picture, sounds. Then the resources IRC, so the same resources that are in the folder but compiled. And then the lib folder that when, for example, you are create an emulator on the Android Studio, so you are able to choose which processor you want on the emulator, like ARM or x86. So in this folder, you can find the compiled source code for the processor. So then, to start the reverse engineering process, we need to get the APK to start to work on it. So if we have an Android device, we can install for example, these two tools, the APK Optic and the Astro File Manager, that it will generate a backup of the application on your device, and then you can, with this APK, you can work with the compile and disassembly. Also, we can use the Android debug bridge to pull the APK from the device. And if we don't have any device, so we are using emulator for the testing, we can use a website that is called APK Pure. So basically, we need to go through the website of Google Play and copy the URL of the application that we want to download and paste on the APK Pure, and automatically we will have our application ready to start the reverse engineering. So then some difference about the compiling and disassembly and APK. The compiler basically is we have like the Java code of the application, like a reinterpretation of the source code of this application. So then for us, it's easy go through this Java code and read and understand what are the application doing. And then we can look for those function or method that we want to change for our own purpose. So then the disassembly, it will be more to the low level. So we are getting the assembly code of this application. In other way, we are getting the SMALI files. So in this SMALI file is where we need to make all the changes that we have to make the changes for our application to change the behavior. So then, good question is why we have to disassemble the application and not the compile for change the behavior of the application. is basically because sometimes when you are decompiling the APK, there are some method that you cannot decompile. So then it's easy to, if you want to change anything, so there are some functions that you don't know what they are doing. So it's, and the way that you have to do this on the smiley files, so this is where you can modify anything, then recompile, and install the application on your device. So for example, the compile is when you are developing any Android application, you start with your Java source code, then you use some Java compiler, you create the jar, and then with some Dalvik virtual machine compiler, you create the text file. So there you have all the source code. So then we start having the text file in the APK. So then we need some Java decompiler to get the jar, and then some, well, dex to jar to get the jar file, and then some decompiler to get the Java source code for the application. So then one tool that we can use for decompile, so go from dex to jar, well, it's dex to jar. So it's basically convert all the Dalvik bytecode into Java bytecode. So, and with this tool and combining with GDGuy or Luiden, we can have the full process of decompiling. But, and one thing that I want to focus that even both are Java decompiler, they produce different output. So here I will put the same screenshot for decompiling with GDGuy and Luiden. And we can see in the method game view, we have the arguments of the application, but we have Boolean, param Boolean 1 or and param Boolean 2. So we don't know what are these variables or for what it's doing. But if we compile the same application with Luiten, we can see more accurate output. So we know now the name of the Boolean, the name of the variable, this Boolean, force, well, these two, and then we have more, one method that the GDGuy didn't detect, so we have more accurate output of the application. So then for me, it's much better to return the GDGuy to understand what the application is doing. So then the second point is disassembly the application. So it's basically, instead to go from Dex to the Java, we are going from Dex to smiley files. So how I said previously, the smiley file is the same as Java, but all the assembly code of the application. So then for disassembling the application, we can use the APK tool. So it will convert from the Dalvik bytecode into a smiley source. So then, and this is because the text files are unreadable, so we need somehow to transfer these files in somehow we can understand. So this is how a smiley file looks like. It's similar to assembly code, and here is where we need to modify the application. So, well, the links you cannot see very well, but for example, in these two links, you have all the opcodes for the smiley files. And for example, if you have one application and you decompile and you know that you want to modify any condition, so any conditional, so you know that, for example, this normal if into the assembly language, it will be like this. So then we only need, for example, to copy and paste this if in our smiley files, and it will be done this if. Then another thing that it's important in our process of reverse engineering is saying the APK. So after we modify our application, we need to sign the APK, because if not, on the device, you will not be able to install it. So we can execute this command using the sign apk.jar, or if some of you use the AppUse, just clicking in recompile the application and automatically will sign the application. So then now I will show you all what I said previously, like a small demo. So I use for this demo a game, it's called Clumsy Bird. So I don't know if you know. So basically, it's, well, you have like a bird, and the bird is flying over the screen, and you need to touch the screen to go up, and if you don't touch the screen, the bird go down, so you need to avoid all the obstacles in the screen. So for this demo, I used the APK use. So when I upload the APK to this application and decompile it by using LUI10, after analyze all the Java classes, I found on the bird.java that we have one method that if the bird hits something, it will be game over, and then the method pause. So then the trick here is put the game over on the pause. So then when the bird hits something, the game will not over, and only will be over when you click the pause button. So after we decompile the application, we disassembly the application to get the smiley file. So we need to go to the same file that we found previously, the same code, so bird.smiley. And we found the same method, public, bird hit, and the pause. So then we need to add the hash key before the sentence that it will be like a comment. It's like this sentence will be not counting on the application, and we will put on the public pause method. So when you hit pause, the game they will over. So then the output of this application, well, this game using that is that actually the game, you can touch everything, so the game will not over. And yeah, when you hit the pause button, so the game will be over, and then you will have the score. So then at this point, if we can read the source code of the application and modify the behavior, it means that it doesn't have enough binary protection, because in theory we shouldn't be able to read the source code or modify. So then for this reason, I will show some techniques to mitigate this lack of binary protection. So one of these thing is detect if the Android is rooted or not. So for this, we can check if we have the test key, so the raw.build tags on the source code, check if the device have a OTA certificate. So if we don't find this certificate on the device, means that they are using a custom ROM, so it's kind of, rooted device. Check for several no-rooted APK, like Android.zu, or check if they have some sub-binary on the application, or query the su command, and if we get like a zero as a output, so it means that the mobile is rooted. Also, we can embed it in the source code the signature of the application. So on the runtime, the application will check the signature. So if it's the same, the application will launch, and if not, so that you will not be able to open the application. So here is a good way to use string encryption to the signature. Then one good thing is obfuscate your source code, and sometimes the tool are able to encrypt a string in your source code. So here is the most known obfuscation tools, and down you have two links that explain how you can decrypt strings. So the method one is they create some parser method. So you have to upload one smiley file by one, and they will try to decrypt the string. And the second one, this is 1 month old, so it's quite new. It's called Dex Oracle, and basically, if you put, running the application, you put an APK, it will be disassembly the APK, take all the smiley files, and then they will run over all the files 3 plugins. That one is for if you are using obfuscation with Dex Protector. Then another one if you are using some Java encryption or common string encryption. So they will try to run this plugin, find any pattern or the encrypted string, and give an output, a clear output. So here is what is the well, source code with the obfuscation, and after running these tools, we can see like everything that is decrypted. And so after the decrypt application, it will create the APK, so we can decompile and do all the reverse engineering process. A different technique is that we can check if the application is running on the emulator device or not. So we can check by if the hardware contains the goldfish, or if you have the QEMU1, so it means that you have one device emulator, and so on. So the application probably will not be open if you are put this in the code. Or also if you have the debuggable flag enabled. So if the application detects that you are trying to debug, so probably will stop. So then for this demo is how we can bypass the anti-emulator detection in Android. So here we have in our device one application that we try to open, but we cannot because it's running on an emulator device. So for bypass this, we decompile the application with return, and we see in this part of the source code that on create, we have some here method for check if the application is running on the emulator device or not. So then we follow the same process as before, decompile the application, we modify the smiley files with the hash key to remove this sentence, and then the final output will be like, actually we can open the application on a emulator device, so it's normal hello world. So for recap, all of these, well, the first part of the presentation is we have seen how we can modify the behavior of the application by disassembly and modify the smiley code, and then some techniques to try to prevent this lack of binary protection. So for the second part, I will talk about some malware in Android. So as well, you can see in this statistics graph, in 2011 they have like 126 on the first half, and then in the second half almost 4,000 malware. So after year the malware has increased. So in 2014 it's almost 750,000 malware. So probably now in 2016 will be more than this. So it's something that is quite dangerous. So for this, for this malware, all of these malware were on the Google Play, were removed from the Google Play, but now you can find it in some websites. So I use it for purpose of this presentation. So this is like the game Flappy Bird, one variation, and here we can see that they are using some permission for sending SMS. So it's just a normal game, and they are asking you to give permission to send SMS. So it's something that is suspicious because a game doesn't need to have this feature. So this is like the famous premium SMS. So in the background they are sending SMS, and you have to pay for that, but you don't know. Then another malware, so here is similar on the manifest, they are using for sending and receive SMS. So it's again, so there are permissions that some applications they don't need to have. So here is some list of the most dangerous permission that you can give to applications, since the internet, read the phone state, or write in the external storage your GPS position, then call in the phone, or record the audio, send SMS. So then another kind of malware is the Android botnet. So it's basically if the botnet is for attacking Android user, and can have all of these features if you are able to install this malware on the victim. So since record call, block SMS, take video, photo, send message, record audio. So many things. So this Dendroid botnet, it's look like the Adobe Flash. So for maybe most people, they will think that it's nothing important because they can think that it's like in Windows, Adobe Flash, so they will think it's okay. So, but actually, by installing this application, the person are giving you all of this permission in your phone. So it's basically like full control. So then, now I want to show you how this Dendroid botnet works. So a friend let me to install this botnet in his phone. So we have here the control panel of the botnet. So here we have the two devices. So then we select which device you want to work. And now we are trying to send this message from my friend phone to my phone using this, this interface. So this is my phone. So actually we receive the message sending by his phone to my phone, but using the botnet. Also, another kind of malware is the Droid Dream. So this kind of malware basically are try to steal sensitive data from your phone, like the email, IMSI, the device model, and etc. So for example, here is another application that was in the market. It's Spain for draw something, but this application, they were asking you to give your GPS position and read the phone state. So, well, I don't know if you can see very well, but here is recollect all the information from your phone and get ready to send it to the attacker. Here is, well, the same. It's another application, but also with the Droid Dream malware. So they are trying to get the phone state and internet and read the phone state. So it's the same, that some application, they have more permission than they need, so sometimes it's malware. And I think this is the last malware that I will present today. And it's about the GM botnet. So it's for display phishing page on the banking application. So they have similar features than the previous botnet, but also they have the ability to wipe your device storage, so completely. And well, here we can see all the permissions that you are giving to the application, like in the previous botnet. But then one maybe funny thing of this botnet is it will only affect you if you are not Russian. So on the application, they are checking if let's say the language of your application is Cyrillic, then the application will not do anything. If you are not Russian, then the application will infect you. So then how we can, let's say, protect this? So maybe don't buy Android unless you are Russian, but joking. So turn off the allow installation from unsecure unknown source. Then regarding the offset permission, it's depend of the Android version, because I think in the Android 6.0, all the permissions are in runtime, like in iOS. So when you open the application, they are asking you if you want to give this permission or not. And under maybe like 4.4.2, before, when you are installing the application, you have like a pop-up, and they are asking you, do you want to give all of this permission to the application? So maybe now is much better than before. So never open any attachment from unknown sources, and also never click on any link or SMS from that someone can send you to your phone. So I don't know if someone have any questions.